So I thought we'd start off this video by showing the end result of this video, and that is we have a Raspberry Pi here with a web server running. We have 4 LEDs that are connected to the GPIO pins, and we have an iPad here with Safari open, and we're going to the IP address of the Pi, which in this case is 192.168.18.105. And so what we have here on the top is we have 4 toggle buttons that turn the LEDs on and off. So we just go ahead and hit those one at a time. And you can see the LEDs will go off as we hit them. And then we have 4 momentary buttons on the bottom that will turn the LEDs on as long as we hold them. And we go ahead and keep the LEDs on by just hitting the toggle buttons. And not only that, we can actually do several button presses at the same time. So I can go ahead and hit this LED, turn it on, and I can go ahead and hit this one and turn this LED on. And then let's go ahead and just toggle these off here. And I can go ahead and hit this one, and I can go ahead and hit this one. And all 4 LEDs are on. As I release the buttons here, they turn off individually. And not only that, our Pi can actually handle multiple users at the same time. What I have open right now is I got my iPad on the right here with just one page open, and then I have my laptop right here, and I actually have 8 browser windows open, all pointing to the same Pi. And it will display, they'll all display the feedback instantaneously from the Pi. And I could do it here. I could also do it from the Pi here. And you can see they all get feedback. And that is the power of WebSockets. With WebSockets, you can have multiple users connected and you get instantaneous feedback to all of them without having to refresh the web page. So this sounds like something that you're interested in. Well, watch on and I'll show you how to do that in this video. So for purposes of this demo, I'm going to use the Raspberry Pi desktop OS with recommended software, and I'm going to use the one with the release date of December the 2nd, 2020. So all you do is go to the Raspberry Pi website, hit the download button, download the file. I've already done that, so I'm not going to do it again. You're going to unzip that file, and then you're going to burn that image to the flash card using whatever flash burner you want to use. A lot of people use Etcher. I myself personally just use the USB image writer that's built into Linux Mint, but that's up to you. But you download that file, stick it in your Pi, boot the Pi up, go through the initial setup, and you should be ready to go. So after you get your Raspberry Pi set up on the first time setup, you want to go to the Preferences and then Raspberry Pi Configuration. And what you want to do is go to Interfaces. You want to enable Remote GPIO. That allows you to change the GPIO pins to turn your LEDs on and off. If you want to manage your Pi remotely, like which I'm going to do here and I am doing here, you're going to want to enable SSH. And if you want to do a remote desktop like I'm doing right here, you're going to enable VNC also. So lastly, you're going to want to find out what the IP address of your Pi is. And you do that by just opening up a terminal and entering ifconfig. Oops, if I can spell correctly. And I'm connected by Ethernet LAN port, and you can see the address of my Pi is at 192.168.18.105. We'll use that to remote into the Pi via the SSH, And we'll also use that to access the Pi's web server through a browser. So you need to write down whatever that number is, you need to write that down because we're going to use it in the future. Okay, let's talk a little bit about web servers. I originally started this project using Nginx, but I had some stability problems with that where the web server would crash intermittently. And that may be something that I didn't set up correctly. I just don't know. But I went on to try Apache 2 after that. And I found Apache 2 to be very stable. In fact, it never crashed once on me. And then I used a PHP and WordPress on top of that as my back-end server. But when it came time to implement WebSockets, which you need if you want to do really fast feedback, I just couldn't get it to work. So I started looking for another solution, and I stumbled across node.js. And when I installed that, it worked perfectly, and WebSockets worked very well. And so that is what we're going to use for this project. So the first thing you need to do is you need to go ahead and SSH into your Pi here. And we're going to go ahead and do that here. You notice I have it's SSH-X and then Pi at, and then whatever the IP address of your Pi is. Now you notice I have the -X here. That mainly just allows you to use the X window system through the SSH connection, which allows you to basically pull up GUIs. And later on, we're going to be using Geany as our editor, and that allows us to use Geany through the SSH connection. So let's go ahead and do that. I'll go ahead and key in my password. And we're in. So the first thing we need to do is we need to go ahead and update our Pi. So we'll go ahead and do that. I've already updated, so we'll come back. It should be all up to date. And it is. And then if it wasn't, you would go ahead and do upgrade on top of that. And that's okay. And then lastly, we'll do a distro upgrade. Okay, so there we are. We need to find out what version of processor we're using, though, and that is, we'll type in uname -m, and you'll see we're using an ARM version 7L. So we'll go to nodejs.org here. And you might be just tempted to click this download link here. The issue is I'm doing this from a Linux computer, Linux Mint in particular, so it's going to download the version for my Linux Mint. So instead, we want to go to the downloads folder here. And here it has all the different versions of Node.js. And the one we're interested in is the ARM 7, which we just found out. And I had issues with Node version 14.15.4, so we're not even going to use that version. Instead, we're going to drop down to our previous release, and that is Node 12, and that one I know does work, so that for at least the immediate future, that is the one I recommend that you use. So we'll go ahead and click on that link. And then you'll see all the different packages here, and we want the ARM 7 version. And we'll scroll down here, and there we go, there it is. And there's two versions. We want to get the one with the XZ extension. So we'll right-click on that. We'll copy that link location. And then we'll go down to our Pi. We'll change our directory to the downloads folder. And then we'll do a wget, and then we'll paste in that link. And it just got Node.js for us. Okay, we can go ahead and close this up now and bring this up here. Actually, let me close this. We don't need that. Okay, so let's do a directory listing here on our downloads folder, and you'll see we have a zip file here, or an archive file. We need to unpack that, and we do that with this command right here. And of course, you're going to, if you're using a different version of node.js, you're going to change the last part of this. So we'll do that, extracts all the files, and then we do another directory listing. We see we have a directory called node version 12.2 la da da. So we'll go ahead and switch to that directory. And do a directory listing on that directory. And you see we have a number of files there and a number of subdirectories on top of that. So basically all you need to do to install Node.js is basically copy all these files and subdirectories to your user-local folder on your Pi. And so we'll go ahead and do that right here. And believe it or not, Node.js and the npm manager are installed. And you can confirm that by typing in node/v, and you see we're using version 12.20.1. I'll go ahead and update my documentation to have that version. And then we'll go ahead and check if the Node Package Manager is running, or npm it's also called. And you see we're running version 6.14.10. We'll go ahead and update our text here. Okay, so the next thing we need to do is we're going to create a project folder, and we're going to go ahead and make a directory called web server in our home directory here. And then we're going to switch to that directory. And then we're going to run npm init, and that initializes the package manager. This is not an absolutely necessary step, but I recommend that you do it, because if you don't do it, you'll get a bunch of errors when you install packages. Okay, so it's asking what you want to call this package name. Web server, that's fine. We'll just go ahead and keep that. Version 1 is fine. Description, we'll call this web server for Pi. Entry point, that's fine. Test command, we don't need that. Git directory, we don't need that. We'll just leave that blank. Keywords, we won't put any there. Author, we'll say Steve's projects. License, we're going to go ahead and do these MIT license. Is this okay? Yes. And that's it. So if we do a directory listing now, we see we have a package.json file. And basically that gives you the dependencies of your project. So the next thing we need to do is go ahead and install a few packages. And the first one we're going to install is on-off. And what on-off does, it allows you to control the GPIO pins on your Pi Viva Node.js. So we'll go ahead and install that package here. Install. We got one warning. It said that there's no repository field. Oh, that's okay. We don't have to worry about that. And then the next package we need to install is socket.io. And what that will allow is that will allow us to use WebSockets. And so it's npm install socket.io and then -- save. And you could also put a -g field in both of these commands, and they will install it globally. But we're going to leave that out. And basically, if you leave that out, you can only use these packages in this web server directory we created or any subdirectory below it. So let's go ahead and install that. And no errors there. Okay, the last thing we need to do, there's a little fact that a lot of people don't know with Linux, and that is if you're trying to set up a server, like a TCP server, like a web server on port 80 on Linux, that has to be run as root normally, and the last thing you want to do is run your web server as root. So there is a way around it, and that is to install this particular package called libcap2-binary, and we already did an update, so we don't need to do that. But let's go ahead and install that package. And what this will allow us to do, it will allow us to run a web server on port 80 because it's below 1024, and without having to run Node as a root user. So this command here, now that we have that package installed, which turned out it was already installed, this is the command that will allow Node, just Node alone, to use any port below 1024 as a server port. So let's go ahead and execute that command, and it's there. Now, if you want to check what packages do have this extra privilege, like let's say you want to check all your programs in your USR directory, you can type in git cap -r for recursive and then your directory that you want to check, and it will scan the directory and it will tell you all the programs that have these elevated privileges. And as you can see, the only package that does is just Node. So let's get our web server going now. So the first thing we're going to do is we're going to go ahead and go to our downloads folder. Let's go ahead and do a directory listing. And we no longer need this node folder here. We've already moved those files to the proper folder, so we just go ahead and remove that folder completely. And we do that with this command. And I'm going to go ahead and leave this archive file here because in case we have to reinstall Node later on, we can. We already have the file. So the next thing we do is go ahead and get the code, and you can get the code at my GitHub page. And so basically you do a wget and then this very long address. We'll go ahead and get it. And then let's do a listing. And now you see we have a file called main.zip. That zip file has all the code. So let's go ahead and unzip that. Let's unzip. And let's go ahead and change our directory to that folder. And let's do a listing. And there are our files. And so the next thing we want to do is we want to go ahead and create a folder to move all these files in. So what I'm going to do is create a subdirectory called GPIO in our web server folder that we've previously created. And we're going to put all our files in there, and because it's under that subdirectory web server, our node packages that we downloaded will execute in that directory also. So we've created that directory, so let's go ahead and copy all these files in our current directory to that folder. Keep from deleting it. So we'll go ahead and copy those files over. And then let's go ahead and change our directory to that folder. Paste. And then let's do a listing here. And so you'll see several files in here. This very first file is just basically these instructions here on the left. So you have these instructions to refer to if you need to. We have a MIT license, that's this next file. We have a public folder. The public folder contains all the files that your web browser can download in order to run the web page. And so let's go ahead and take a look here in that folder. And you see we have an index.html file. That is the very first file your web browser downloads when you go to the IP address of the Pi. And then main.js here, that is the JavaScript code that actually runs on your web browser, in your web browser, not on the Pi. And then CSS contains our cascading style sheets. The 404 HTML, that's just basically a dummy file that gets called up if you attempt to access a web page that doesn't exist on the Pi. It will basically serve up that page instead. And then we got a folder called images. And the only file in the image folder right now is, we'll go ahead and do a listing, is this favicon-.ico. And what that is, a lot of web browsers will complain if you don't have that file. And basically all it is when you bookmark a web page, you'll see a little icon by that bookmark. And this favicon icon is that little image you see. So that's the only purpose of that file. So let's go ahead and go back to our main directory here, or our GPIO directory, do a listing here. And so now all we have to do is type in node web server. Actually, before I do that, let me just go ahead and clear the page here, get a clean slate. And let me do a listing again. And all we have to do is type in node web server .js, and that will run our code. And so you can see the server is running on port 80, and by default I turn on GPIO 21 and 16, but I turn off 26 and 20. So it's just letting you know what the states of the files are. So let's go ahead and bring a web browser into the picture here. So let me go ahead and go over here. And so let's go ahead and type in the address of the Pi, which in my case is 192.168.18.105. And there you go. And as you can see, GPIO 16 and 21 are on. That's what we initialized them to. And so you can go ahead and turn them on and off. And the video in the beginning of the video is showed you how that all operated. And so that's basically it. We have our web server running now. Now, if you want to go ahead and stop the web server, you just go over here to our terminal window and then hit Control-C, and that stops the web server. So now if I go ahead and try and do a page refresh, it says the page doesn't exist. Anyway, that's it. I'll go ahead and do some quick look at the code here. But that's all basically you need to get your web server running. Okay, so let's take a little more look at the code here. So let me go ahead and close this up. One thing I failed to mention here, let's just do a directory listing. The README file just basically refers you to this document and also refers to this YouTube video. And then the webserver.js file, that is the JavaScript code that runs on your Pi. So when I typed in node webserver.js, it was executing the code in that file. And so that runs on your Pi, and that's also called the backend. So let's go ahead and start Geany here. That's the text editor that I'm using here. And we'll go ahead and start that. So the first file that your web browser calls up, like I said, is the image.html file. And I'm not going to go into a whole lot of detail here. I just want to cover a few highlights. But basically, like I said, your web browser downloads this file first. And in here, it's got a couple of references. Here's that reference to the favicon image file that a lot of web browsers like to see. And here is a link to our cascading style sheets right there. And then we got our body of our web page here. And in here we have our 4 little containers here that have each GPIO pin on them. They're all little separate little containers there. And about the only thing I'm doing special here is the toggle button, where you toggle the pin either on or off. It has an ID of, like this first one, GPIO 26, but you see I have a disable command at the end of this. And the reason for that is normally the normal behavior of a checkbox is when you press that button, first of all, you got to click it. You can't press and hold it. And then when you click it, it will toggle that checkbox from one direction to the other. And we don't want that to happen, because what we want is we want the Pi to actually send that feedback back to our web browser. So we want to disable that toggling action, and that's what this command does here. And then this button here, that is our little momentary button, and I give it an ID of GPIO 26M for momentary. So we have our other ones here, and that's basically it. And then down here is our reference to our JavaScript files. So the first one is socket.io JavaScript file, and if you look for that on your Pi, you won't find it. And the reason why is It's actually generated by node.js on the fly. So if you want to look at this file, it's actually in the other documentation. So let me just go. First of all, let me go ahead and turn this. Message pane off down here on the bottom. So let me go ahead and move that over here. Kind of get this lined up here. Okay, so if you go up here to this documentation here, and it's right here, socket.io. So if you actually want to look at that socket.io file, you can get it by just opening a terminal on any computer that can do a wget command, and you just do wget and then the IP address of your Pi, and then this, and that will download that file for you, and you actually go ahead and take a look at it if you want to. And then this is our call to our main.js file, and that's like I said, the code that runs in your web browser. So that's basically it for the index file. So let's go ahead and take a look at our cascading style sheets. There's a lot in here. There's nothing too difficult about it, but it is just a lot of information. Basically, every web browser has different defaults for, what kind of font it displays or how the text is oriented, and you don't want to rely upon the defaults of those of the web browser. So in this case, we're going to say here font family. I want you to do Arial. If you can't do Arial, go ahead and do Helvetica. And if you can't do that, go ahead and do this font here, which virtually is all web browsers have that font in it. Then we have a no select. That was the file that we call in the index file right here. No select class, no select. And all that does, like I said, I believe, is that just keeps, when you're pressing a button, it won't bring up the clipboard on your touchscreen device. And then here's our GPIO containers, each one. And if you look in there, there's a float command. And what that float command does is if your screen is narrow enough where everything doesn't fit on the width of the screen, the float command will do is rearrange the objects so that they don't go off screen, basically. And so if you look at this project on an old iPhone or something like that, it probably won't all fit on the page. And so what you'll see is the various GPIO containers, they'll actually will move down to the next level so you can see them. Text align, this is the thing where we say we want all text to be center aligned. This right here is defining how that slider looks. It's normally just a checkbox, but this changes the look of it to be a slider. What I suggest, if you want to look into this further, go to W3 Schools. That's where I got this at, and they got all this code right there on their website. And here I'm defining how a button looks and behaves. And so that's basically it. I'm saying 60 pixels wide, and the width is auto. So if I put text on there bigger than what that 60 pixels is, the button width will automatically increase in size. Got the height of 50 pixels. Again, I set the font family. The color is black for the text. The background color is set to a gray color here. This gives the edges of button a rounded look. So there's all these things, and it's just way too much that I could cover in this video. This video is already getting kind of long, but I suggest that you look at some of the resources I have in the document here. If you have any questions, so let's go back up here, right here, useful resources. So go ahead and look at these things in particular here. These videos from Traverse, from this person here, I found particularly useful. And here's just the various videos he has on basically HTML, JavaScript, node.js, CSS, and whatnot. So now let's look at our main.js file. And this is the code, that JavaScript code that runs on your web browser. So basically the first thing I do is I create a variable called socket, and that basically starts socket.io is basically all that does. And then I add a few event listeners. And what you'll notice here is I have this little thing, if mobile. So if you go down here to the very bottom, you'll see here's where that is mobile function is defined. And all that does is it tells you if it's a mobile device or a touchscreen device, or if it's a desktop. So mobile devices and desktops have different methods of reporting whether something is pressed. And on a mobile device, it's touch start and touch end. And there's also a touch move. And then on desktop devices, if you're using a mouse, it's mouse up and mouse down. And so if we're doing a mobile device, we add these event listeners. And if it's a desktop, we're calling these event listeners. So like if when you press a button on a touchscreen, it's going to call this touch start function. And if you look down here, there's a function called report touch start. And so it calls this function right here. Okay, so the next thing here is this here updates the feedback when the server changes the LED state. So our Pi web server will actually send updated messages to your web browser when the state of an LED changes. So right here, if the state of GPIO 26 changes, it basically decodes it, and then it updates your web page with this new data. And likewise for GPIO 20 and 21 and 16. Okay, so let's go to our touch start here. So one of the issues I had with the toggle buttons is if you just click the button, it would work right. But if you actually pressed and hold, the toggle function would never happen. And it only would happen when you release the button. And I wanted to have it happen when you first touch the button. So that's the purpose of this. And this was basically a workaround right here to get that to work, because basically there's no command to do that normally. And so this is calling up, it's actually looking at what they call the document file. And then if it sees in that document file that you push the GPIO 26, then what it does is it sends that command, and in this case, I sent a GPIO 26-T for toggle. This is being sent to the Pi. And the Pi then updates the feedback on the LED and then sends the feedback back. And then this is where your web browser gets it back right here. So this is coming from the Pi. This is going to the Pi. And so I do that for each of the, I test each one to see if one of those buttons has been pressed on that touch start. And then here I'm testing if you pushed one of the momentary buttons below. And if you push like GPIO 26, the momentary button, it will send a GPIO 26 command with a 1 to the Pi for the data. And that 1 tells the Pi to turn the LED on. And then likewise under the touch and here, when you release the button, this function gets called and we send a GPIO 26 with the data of 0 to the Pi, and the 0 turns the LED back off. Likewise, exact same commands for the mouse down function if you're on a desktop. Exactly the same as the touch start and touch end, and another one for the mouse up. And then here's a function for touch move if you want to use that. I'm not doing anything with that, but if after you touch the Pi and you start moving your finger around, this function gets called and it lets you know where you're moving your finger at, basically. And then again, this is the function that determines whether you're a mobile device or a desktop. So let's look at the webserver.js. This is the backend code. This is the code that runs on your Pi. And so there's a lot of stuff here, but basically, if you have any questions on this, like I said, refer to these references here. But basically here we're starting our web server right here on this very first line, and we're assigning it a function called handler that gets called whenever your web browser talks to this, to the Pi. It calls this handler function. If you look down here, there's a handler function right here. And that handler function basically serves up the web pages, tests that the web page exists, and then it serves them up. If you're calling for an image file, it sends back the proper response for that. Here it reads the file. If that file doesn't exist, it calls the 404 HTML file instead. But if that page does exist, then it serves that page up. So right here we're defining our GPIO pins. Basically, we're telling Node, the on-off module in particular, to go ahead and set up these pins. And then right here, I'm initializing the value of those pins. So like you saw before, GPIO 26 and GPIO 20, when you started the web server, it defaulted those LEDs to off, and it defaulted GPIO 21 and GPIO 16 to on. And so if you wanted all the LEDs to be off when you start the Pi server, you would change these two values to 0 here. Right here, we're defining what port we're using. So if you wanted to use port 8080 instead, you would go ahead and put in 8080 here instead. And where you might want to do that is if you want to run several web servers on your Pi at the same time, they all can't be having the same, they all can't be using the same port. And the difference is when you open up your web browser, in addition to keying in the IP address of the Pi, you would go ahead and put a colon behind that and 8080, and then it will be able to access the Pi then there. But the default is 80, and so if you're using the default, you don't need to put in that colon 80. You can, but you don't have to. Here we're starting the web server, and here we're running the LED values to the LEDs when the web server starts. And then we're also printing out what those LED values are and printing out what port the web server is running on. You saw that at when I went ahead and started the node space webserver.js. And here's our event handler, and that's what calls up the web pages. When you terminate the web server, when you did that Control-C to terminate the web server, this process gets called here. And all this is doing is it's releasing the GPIO pins so somebody else can use them. And that's basically it. That's all it does. And here's our socket IO functions here. So when you press a button on the Pi, you're actually not using this handler function. Instead, you have a direct connection via WebSockets to this right here. So when your web browser first connects, it's going to call this function here. And then in the console, I print out, and this is on the Pi console, a new client has connected, send LED status. And then here I'm sending the LED statuses to that client that just connected. And then, and so when you do socket emit, it sends it just to the client that's requesting it. If you do a IO.emit, that will send it to all the clients. So when your web browser calls the GPIO 26 toggle button, that's the little toggle switches on the top, first thing it does is it sees what the current LED status is, and it flips it around the other way. So the LED is off, it turns it on. If the LED is on, it turns it off. And then it prints it out to the console. That's just some debugging information, tells you what the new value is. And then here it writes it to the LED right here. It's actually writing that new value to the LED to turn the LED on or off. And then right here, I'm just saying a console log, we're going to go ahead and send this new state to all the clients. And so here's that IO emit. And this IO emit then sends this new status along with it sends GPIO 26 along with the new value to all the clients. And so all their web pages get updated with this new value. Same thing for GPIO 2020, GPIO 21, and GPIO 26 toggling. And then if somebody presses the momentary buttons, they send this GPIO 26 command along with the data. And so the first thing we do is read that data into our variable that we defined above. And it's going to be either a 0 or 1. And then we check and see if the LED is already in that state. If it's not in that state, we go ahead and write the new value to the rewrite the new value to the LED. We go ahead and console log it out for debug information. And then we also emit it back all to the clients. Now, actually, we don't need this in here. But if you wanted to update the HTML file so that you would see those button presses on all the web browsers that have it open, you could do that. I'm just not doing that here, but this is how you would do it. You would emit it all back to the clients, and you would update your HTML file to use the feedback from the Pi rather than the default action of that button that's normal in HTML. And so we got for all four momentary buttons here. And then the last thing here is on disconnect. Whenever somebody disconnects, we just send a console log to the node.js console that says a user has disconnected. And so that's basically it. There's a lot here. I know it, if you've never done web development like me, this is very, very overwhelming, I guess you could say. And so that's why I made this example, to help other people trying to get started with this. And now, I do have a full-time job, so I don't have a lot of time to answer questions. So if you ask a question, oh, I can't get this to work, I probably won't respond. But that's why I'm giving you these resources here. You just have to look it up yourself. But hopefully this gives you a head start. If you like this video, go ahead and give it a like. I plan to do some additional ones here. Additional web server projects, in particular talking to third-party devices. So I should have some other videos coming up here shortly. Anyway, good luck. I hope you found this informative, and we'll see you later.